The height of a baseball in feet, t seconds after being hit, is modeled by the equation h equals negative 16t squared plus 75t plus 4.7, while t is greater than or equal to 0 and h is greater than or equal to 0. Part A. When will the ball reach its greatest height? It is important to recognize in this question that is asking about the greatest height that we recognize what we're dealing with is a parabola. And not only is it a parabola, but specifically, it is a parabola that opens down. Because this is a parabola that opens down, we can identify that the greatest height will happen at the vertex. So to answer this question, we begin by finding the vertex. To find the vertex, we use the formula t equals the opposite of b over 2a. In this particular situation, that would become that t equals the opposite of 75 over 2 times negative 16. Throwing negative 75 divided by the quantity 2 times negative 16 into a calculator, I obtain 2.34375. Now normally when we're finding a vertex, we also need to find the other coordinate, in this case the h coordinate. But before we go ahead and do that additional work, I want to go back to what the question was asking. The question was asking when. When will this happen? Notice that the question did not reference what the height would actually be, other than it would be the greatest height. Had we been asked when will the ball reach its greatest height and what will that height be, then we would actually have to calculate out what h is. But since this question is only asking when, I do not need to know what the actual height is. So because of that, I won't actually find the height. I will simply answer the question. When will the ball reach its greatest height? The ball will reach its greatest height 2.34375 seconds after being hit. In part B, when will the ball hit the ground? Well, when being asked when will the ball hit the ground, we have to recognize what we're being told. When we're told that the ball will hit the ground, we're being told something about the height. When the ball hits the ground, its height will be 0. So we are indirectly being asked, when will the ball have a height of 0? To answer this, we'll put 0 in for the h, and that will give us the equation. 0 equals negative 16t squared plus 75t plus 4.7. To answer this question, we will use the quadratic formula. As a quick refresher, the general form of the quadratic formula is that t is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this particular situation, that will become the opposite of 75 plus or minus the square root of 75 squared minus 4 times negative 16 times 4.7, all divided by 2 times negative 16. Simplifying what's underneath the radical first, 75 squared is 5625. Multiplying negative 4 times negative 16 times 4.7, we get 300.8. And in the denominator, we have 2 times negative 16, which is negative 32. Adding that 300.8 plus the 5625, we get 5925.8 under the radical. So we have negative 75 plus or minus the square root of 5925.8 all over negative 32. At this point, this is simply something you want to put into your calculator. So the first possibility is negative 75 plus the square root of 5925.8 all divided by negative 32, and that comes out to be about negative 0.062. The other option would be negative 75 minus the square root of 5925.8, all divided by negative 32, and that gives us t is about 4.749. Recognizing that the t value is telling us how long since the ball has been hit, a negative value would represent some time before the ball was hit, so that answer does not make sense in context. So to answer the question, when will the ball hit the ground? The ball will hit the ground about 4.749 seconds after being hit.